Okay, so this is lesson 5.2, solving exponential equations. Lesson 5.2, solving exponential equations. We talked yesterday that an exponential equation, now we're going to have variables as the exponent. Okay, so that's something that we haven't seen yet, but our variables are going to be in our exponent. When we're solving these types of equations, okay, the first thing that we want to do is make sure that we have the same base. All right, so number 2, it says the same base. We're going to make sure that they have the same base. And when we say same base, I'm talking about like x to the 5th. Well, let's do a different example. Let's do 5 to the x and 5 to the 2 plus 5x. The 5s are called the base. Okay? So if your bases are the same, what you're allowed to do is drop the bases. So that's step number 3, is going to be able to drop the bases. And then you're going to set the exponents equal to each other, and you're going to solve it like an old algebra problem. So if you're looking at example 1, notice that they both have a 2, right? So your bases are the same. So when your bases are the same, you're able to just cross them out, drop the bases, and the exponents drop down to be the actual problem. So then you have x plus 1 equals 9. That's super easy, right? We get x to be 8. If I were to plug 8 back in for x, I would have 2 to the 8 plus 1 equals 2 to the 9th. What is 8 plus 1 up here, though? 9, right? So you get 2 to the 9th equals 2 to the 9th. Okay? So when you can plug x back in just like you always have been able to do to solve it to make sure you have the right answer. Okay? And then if you look at number 2, bases are the same, right? So if you have 5 and 5, what are those 5s going to do? Cancel. And then you have 4n plus 5 equals n minus 7. And this is now a problem that you can solve. Subtract n, that gives us 3n. If I subtract 5, that gives me negative 12. And then I get n is negative 4. You okay so far?
This is super easy.
Okay, so let's look at number 3. Now we have all the same bases, but if you look at example number 1, or I'm sorry, notes, it says use the properties of exponents to simplify each side first. So if you're looking at this, if you had something like this, if you had x to the 5th times x to the 3rd, what would you do with your exponents?
Multiply them.
Would you multiply them or would you add them? You add them. You would multiply when it looks like this, when you don't have a base.
Oh, I thought
Okay.
the dot in between them certified multiply.
It is, but when the rules say when you are multiplying, you're actually adding them. Okay, so that would be 5 plus 3. So if I'm looking at this, same concept here with the 3's, what am I actually going to do with those exponents up there? I'm adding these, right? Just like I would have added over here, 5 plus 3 to be 8. So I have 3. What's k plus k? 2k plus 2. Everyone see where I got the 2k plus 2? I'm adding these two exponents together up here and just giving it one base.
Why wouldn't we cancel out the 30s?
Because we are not, it's not all the way simplified. We can't cancel out the 3's yet. We're not all the way simplified. All right? So over here, with this example, x to the 5th times x to the 3rd is x to the 8th. Right? You don't cancel the x's out. You just simplify it to be x to the 8th. So you have a base and then an exponent. Same concept there. All right, and then this 3 to the 5k minus 1 doesn't change. Now you have a single base on each side, right? You only have one base on each side. And your bases are the same. Now what are you allowed to do, Taylor? Now you can cancel your bases out. And you get 2k plus 2 equals 5k minus 1. And we can solve that. Go ahead and solve it. You guys all right with that? K equals 1. All right, let's look at example 4.
So,
Again, it looks like we are, quote, multiplying our exponents, but what are we really actually going to do? Okay, go ahead and try number 4 then.
would it be safe to say that we do not get rid of the bases until after we've simplified?
Yes, that's what I said, and that's what number 1 says on your paper. So if I add those together on the right side, v plus 2v is 3v. 4 minus 11 is negative 7. Yeah, Aspen?
Correct me if I'm wrong, but when it comes to these problems, you don't multiply the bases, do you?
No. Nope. Because if you look over here at this example with the x's, we didn't do anything, we didn't make that like 2x or anything, right? It's just x.
So you just keep the base?
Yep, same thing. The temptation, you're right, is to do 10 times 10, but we are just going to keep it. Okay? All right, so now that our bases are the same, what are we allowed to do? All right, so let's cancel out our bases, drop the base. So then we add 7. And I get v to be 4. How are you feeling about this? You okay so far? All right. The second type of equations we're going to deal with, though, don't have a common base. So if you look at the next set of examples, they don't have a common base. So our job is to get a common base. So you have your calculator, right? The hint is the single digit over there, that 6, is probably going to be the base for both of them. What I mean by that is this. Can you change 36 to be a base of 6? Can you change 36 to be 6 to the something power? You can, right? 6 to the what power? Second, right? 6 to the second, 6 squared is 36, right? So we can change this 36 to become a base of 6. And you're allowed to do that because it's an equivalent statement. So I can change this. I don't really need parentheses because it's the only thing over there. I can change the 36 to be 6 squared, and it means the same thing, right? It's still 36. I just wrote it differently. Okay? And now it has given me like bases. You guys see that? So now my bases are the same. So what am I allowed to do now? What did you say, Cedric? Oh, what would you do now, Cedric? Good. We're going to drop the bases. And then I have 2x minus 10 equals 2.
This might be jumping the gun, but this is cakewalk.
Okay. You get x to be 6. You okay with that?
How'd you get 12?
If I add 10 over? Waking your brain up today, aren't you? Okay, what about number 6? We can't change 2, right? It's basic how it is. You guys, in your calculator, remember you have this button right here? This little caret button thing above the divide sign? That's your exponent. So you can take 2 to the second, 2 to the third, 2 to the fourth. I mean, when the numbers get bigger, you'll have to do that. But 2 to the what power is 8? 2 cubed, right? 2 to the third power. So we're going to change our 8 to be 2 to the third power. And now my bases are the same. Add 7 over and you get P to be 10. All right, number 7 is kind of a tricky one. I want you to star number 7. When you have fractions, okay, make yourself a note. When you have fractions, you're going to change to a negative exponent.
Actually, that makes sense.
Just write it down and I'll show you. You're gonna, if you have a fraction, you're going to change it to a negative exponent. If you have 1 over 7, that is the same thing as writing 7 to the negative 1 power. You learned that in Algebra 1A or with Mr. Edward in Math B. But if you flip a fraction, okay, you're always going to have 1 on the top, by the way. It's always going to be 1 over something, so we don't have to worry about a different numerator. But it's going to be 7 to the negative 1 power. It means the same thing, you just are rewriting it, okay? So on this fraction over here, because 1/7 is not the same base as 7, all right? So I have to change the 1/7 to be a base. So if I change this to be 7 to the negative 1, now my bases are the same. And now you can, just like normal, cancel the bases. 4x plus 11 equals negative 1. Subtract 11 over and you get negative 12. So x is negative 3. Okay, what about number 8? 2 you can't change. So that's the hint that you could probably turn 32 into a 2. So with your calculator, 2 raised to the third, 2 raised to the fourth, 2 raised to the fifth. Don't shout it out. Just figure it out on your paper. 2 to the what power gives you 32, and then write it down on your paper. Lexi, what'd you come up with? 2 to the 5th power. Anybody else agree with that?
Yep.
Good. Okay, we're not going to take the time to solve these equations out. Just go ahead and mark your bases out. Write this part down, and then we're going to move on. Because you know how to do these. Okay. Let's look at number 9. What do you think the base might be? 3? Okay. So let's see if we can make 27 become a base of 3. We know that 3 squared is 9. What about 3 to the 3rd power? It's 27, right? So now this becomes a little bit different than what we've had to do in the past. Because if I change this to be 3 to the 3rd, I still have that 2x plus 6 there. This is the first time that's happened. Whenever I've had to change a base, it was the only thing over there. But now I have that 2x plus 6, so I'm going to still write it as an exponent out there. We do have like bases, right? I do have the 3's. My bases are the same.
So you just can't, so you just.
I cancel my bases, but now what's going to have to happen between this 3 and these things? Good. Distribute. You guys are on it. Yeah. You're going to have to distribute. Okay?
I thought that would have been the case. I was wondering when we were going to hit one of these.
So we're going to multiply here and here. You got to take it to both of them. Oftentimes students only take it to the first term. You're going to have to multiply to both of them. Okay? So you can rewrite it like this if you want to make sure that you distribute correctly.
Oh, I thought you meant we do it to the whole entire top thing.
I did. 3 times 2x and 3 times 6.
I'm talking about the other one, the 2x.
On the other side?
Yeah.
It's on the other side of the equal sign, so you don't send it over there. Okay, and we can solve this. It's okay to get a fraction. If I subtract 6x, I have 18 equals negative 4x. Divide by negative 4, I'm just going to reduce this. So this reduces to negative 9 over 2 equals x. It's okay to have a fraction. Questions on number 9? Okay, number 10. Sometimes there's a couple ways to do the problem. On number 10, can you make 16 become a base of 4?
Yeah,
You can.
It's a perfect square.
Right? 4 squared. But what if you thought it to be a base of 2? What if you changed 4 to be 2 squared? Y plus 2. And then you change 16 to be 2 to the 4th, y minus 3. Do you think you're allowed to do that instead of just changing one of them to 4?
Yeah.
You can, right? It means the same thing. You just have a little bit more work to do if you change both of them.
You don't have
Okay? You don't have to in this problem. You could have just changed the 16 to be a base of 4. Okay? So if we do it this way and change both of them to be a base of 2, when my bases cancel out, I have 2 distributive problems to do, right?
Or we could just do what we've been doing, right?
Where you multiply it and then write it down. Like not writing this step right here.
I don't know. I think she's doing us a
I
pretty
just confused myself.
Okay. And now you would just have to distribute on both sides and continue working. Okay? We're not going to finish this one out because I know you guys know how to do this. Hey. Also, we're going to continue to write these to where they have the same bases, but we're not going to finish solving them because I know you guys know how to solve them. Okay? So the important thing is learning that new skill about how to change them to be the same base, and then we'll keep going from there, okay? Because I know you guys are all algebra rock stars. You passed algebra 1, so we don't have to do that part of it. Let's look at number 11. Can you change 125 to become a base of 25? Like in your calculator, if you do 25 to the second power, what does that give you? 625. Whoa, we are way above 125. So, you cannot change 125 to be a base of 25.
Can we do a 5?
Can we do a 5? Well, we know that 25 can become a 5, right? 5 squared. What about 125? Let's check. What is 5 to the third power?
125.
Perfect. Right? So now we can change both of them to be a base of 5. So this is 5 to the third. We still have our y out there. And then 5 squared. Questions on how we got that? You're just using your calculator to help you, okay? Drop our bases. And I get 3y equals 2. This one's going to be a fraction. That's okay to have fractions. Okay? Why don't you try number 12 on your own? Pause and try number 12 on your own. Example 12 is going to have to be a base of 2. So 2 to the 4th power, and then you have your 3x out there, equals 2 to the 3rd power, and then you have your x plus 2. You guys getting the hang of this? Okay? Let's talk about number 14. Okay? Let's talk about 14. What's the first thing we need to do on 14?
Handle the parentheses.
Good. Lexi says make it a negative, right? You're going to make the 1/3 become the negative exponent. Remember we wrote that out on number 9, I think it was? So on number 14, we're rewriting the 1/3 as 3 to the negative 1 power. And then I still have my 2x out here. 81 can become a base of 3 if it is 3 to the what power? Daniel says 3 to the 4th. Does anyone agree with that? A couple of you? If you need to, make yourself a note that you need to flip your fraction here with an arrow if you need to. We know that this changes to 3 to the 4th. 2x plus 5. Now your bases are the same, so they're allowed to drop. Four times 2x plus 5, negative 1 times 2x. And you would carry on as usual, per usual. What about 16? Let's try 16. Give 16 a go. Okay, so on 16 we get x to be negative 10. Okay. Anybody not get that? That's not sure what happened? All right, let's look at setting up 17. Just setting it up. So now we're putting a couple of the skills together. So let's take care of the left side first. 64 can probably become a base of 4. That's probably why they gave that to us, right? So let's check 64. Can that become a base of 4? 4 to the what? Okay. So we're going to change this to 4 to the 3rd power. And then remember, what's the exponent of this first term? 1. And what do we do with our exponents when the bases are the same? Thank you, Crystal. We add them, right? So this is really 4 to the 4x plus 1.
Now, which ones are we supposed to add?
When you see the bases here, then you add them. When you draw this example out over here on your paper, x to the 3rd times x to the 5th gives you x to the 8th. Right, you added them. If you have an x to the 3rd, but then in parentheses you have a 5, notice there is no base with that 5. So that's when you would multiply x to the 15th.
So,
When you can see a base for both of them, that's when you add.
So why didn't we just add 1 to the x to the 4x?
I did. What is 1 plus 4x? 4x plus 1. Because 1 doesn't have an x with it, so they're not like terms.
Oh, right.
All right. Okay, and then you would go on from there. Let's take a look at number 19, just setting it up. This one's kind of loaded. We can handle it, though. We're going to take it a step at a time. 1 over 7 needs to become what, Dalton?
7 to the negative 1.
Perfect, okay. 49 needs to become what, Alyssa? What is 49? 7 to the what power? Second power. So this becomes 7 squared x minus 5. And then we saw this 7 x minus 9. Now, before we can add together, what do you think we need to do?
Distribute.
We're going to need to settle this 2 times x minus 5, right? We need to take care of that first. So this becomes 7 to the 2x minus 10 times 7 to the x minus 9. What do we do with these two exponents up here?
I don't know.
We're going to add them together, right? What I just highlighted, we're going to add those together. So 2x plus x is 3x. Negative 10 and negative 9. And now I have like bases. Okay. And again, we're going to get a fraction answer here. Oh, wait. No, we won't. Sorry. It comes out to be a whole number. But on a few of them, we've gotten a fraction answer, and that's okay to have a fraction answer. Okay?
Now, what happens to the other 7? That just goes away?
Look up at this example up here. What happened to that other x? There you go. Always relate it. This is a good test-taking strategy if you have to, I mean, you don't have to take the ECA, but if you did, right? Write an example out that you know the rules for, right? You know x to the third times x to the becomes x to the eighth. You know that. It's been ingrained in you. So take that same type of an example and apply it to this. What happened to that x? Oh, it just combines with it. Okay?
So is this the original mathematical method, or is this an easier way to do it?
No, this is the original.
Cool.
All right, so then your homework assignment that goes along with this, okay? Your homework assignment that goes along with this is homework number 31, page 7 and 8. I'd like you, 7 and 8. I'd like you to do all 18 problems, please. Okay? Actually, yeah, all 18 problems. So if you were absent yesterday, you have homework 30 and 31 to be doing after your test today. Okay?